Hi guys, greetings from Bulgaria. I'm Anton, and today we are going to talk about Thread.sleep in Java for pausing test execution. It has been a while since I shot my last video for the channel, and there was a good reason for that. I was hardly working on finishing my 5 new books about automated testing. They will be released in September, so stay tuned. So in this tutorial I will guide you how to use the Thread.sleep the right way and how to avoid it sometimes, since it can bring you lots of trouble. First we'll discuss in short what the Thread.sleep does exactly, and then we'll automate a simple scenario on the Lambda test playground. Probably at some point we'll have problems and we'll have to use pauses. Of course, in the third part, we'll refactor the whole solution and the tests following the best practices, and we'll fix everything the right way. Don't forget to subscribe to the channel, hit the ring bell so that you get notified when there are new videos published. They are published each week, many things to learn, and also don't forget to check the Lambda test blog. So first, let's talk about the Thread.sleep. In order to understand it, there is a really great article on the Lambda test blog called Thread.sleep method in Java complete tutorial with examples. Here there is a really awesome diagram of how actually the Thread.sleep works, and before discussing that, let's discuss how the test automation engineers and when they use this Thread.sleep. So these engineers that are just getting started, they use this Thread.sleep when they start automating web applications. They want to apply like a pause, hard-coded pause. Many often when the test cannot click a button or type a text in a field, the engineers just put a few seconds of hard-coded pause to wait for a moment and then to continue. Many often we use the Thread.sleep just to debug the web application, but you know, sometimes we forget to remove the pause, or we just use it in order to make the test pass. And the scenario, I think, here you can find many examples of this on this blog post. However, in order to understand it the best way, we're going to create a simple test using the Lambda test playground. If you haven't checked this awesome demo website, I suggest to do so. And by the way, I'm going to in a minute to write code. In the links below, in the descriptions, you'll find a link to the GitHub repo that you can clone, play around. The full source code will be there, and also you'll find also other resources there. Our example that we are going to automate, and by the way, in this example you won't just learn the best practices for handling this asynchronous stuff without using pauses, but also there will be many other useful things, like for example writing webhook headers, which are really basically the core of your automated tests. So if we type here, for example, iPod, and as you can see here we have this autocomplete suggestions that, depending on your network, it will show, for example, after 1 second or 2 seconds, 3 seconds, you're not sure when. And probably this will be the first place where before clicking on the particular product, we'll need to use a hard-coded pause. Then we're going to click the item, and of course here we can do other verifications, for example whether the right product was displayed, the price, we can update the quantity and other stuff. But in our case, we are going to use this compare this product button. We are going to click it, and as you can see, in a few moments, this notification shows up about that the product was added to be compared, and then it disappears. However, again, it depends on the traffic on your website and the vault, these notifications and how they are added, because this happens asynchronously through JavaScript. It may take a while before this is actually done, which means that probably when you click the button, we will need to wait for a few moments until the product is added really. We'll repeat the same for 1 or 2 more products, and then we can click this compare button on top, and again, maybe we'll need to wait a bit until the page has been loaded. This is like a 3rd or 4th pause that we're going to add, and we can verify whether the item's information is correctly displayed, whether they are the right order, etc, etc. But again, this will be one real case if you have to write such tests. So for the job, I created one Java project. We use IntelliJ. I use JUnit as a unit testing framework. If you're not familiar with JUnit, there are like 10 videos about it on the Lambda Test channel, a whole series about JUnit. I suggest to check them. And also about how to set up such a JUnit project with Selenium. Just quickly, I will explain. So we use Maven, not Gradle, but Maven for build system in Java. I use some of the latest versions of Java here as a compiler. We have some dependencies. As you know, Maven is a popular tool for managing the dependencies in Java. So here I just copied, installed the necessary dependencies for JUnit. Also, I have the tool for Selenium. By the way, from this version forward, 4.11, you're no more obligated to use the WebDriver Manager, but still I will, because as you know, right now from this release forward, Selenium will download the necessary drivers automatically for you. But since it's just still in beta, I will leave it here. It's backward compatible. As you know, the WebDriver Manager is responsible for downloading the proper driver. How we do that? Before each test or before all of the tests, we can download the Chrome driver or any driver that you want. As I said, even if I comment this now, the Chrome driver will use the new Chrome for testing, and it will download the necessary driver using the Selenium Manager under the hood, which is one of the major releases right now of Selenium, which is great. But again, for backward compatibility, I can still leave the WebDriver Manager here. What else? We start the browser before each test. We close it, and that's all. We have one test here to check the correct information displayed in the compare screen, whatever. And now let's start automating. First, we need to navigate to the website. I will do that here. Let's make some space and zoom a little bit. So the next job is to find the search screen. Here, let's search for it. Here we can find that by this name, so I can really quick type input, then name using add. You can specify the particular attribute equal search, and this will find this search above, as you can see when it's highlighted. Or you can find it by the placeholder, which is this gray text here. So let's return, and I can type it like this: search input equal to driver find element by XPath input name search. And then we can search for whatever you want, but it can be iPod, it can be IP. Then we need to wait a bit for these suggestions to appear. And in order to do so, this is the first time when we are going to use the Thread.sleep. Here it is. Because we are using the Thread.sleep, if you hover, you will see that it throws interrupted exception, which means that we need to mark our test that it's throwing this exception as well. And after that, we need to find the right autocomplete item, for example AP. So we waited for 5 seconds. Again, AP, let's inspect it. We need to be real quick. So here it is. We have this drop down menu, then so we have this list, right? Then so maybe we can find the whole list by this part of the class. It seems unique. And then inside of it, we need to find the right image. So we have this option, then inside we have a div, then we have an anchor, and maybe we can find it by product ID. As you can see, when we click the link, there is this URI where we have the product ID specified here. So this means that this iPod Touch has an ID 32. So we can combine all of those and write the locator. So we start with the options, and then we need to find an option, not the option. Here we need to find, we can use the XPath contains class, which has drop down menu autocomplete class, then AI, and then inside of it we have a div and then an anchor, and inside the anchor we need to specify the exact product. Again, we are going to use contains, and then we need to specify the href, where we will have product underscore ID equal to 32. In our tests, we are going to modify this to supply it a custom ID, for example 34. As you can see, we found it the next item with a different ID. So we can click any item here like this, but we will need to provide the product ID, right? So we use a string format. I provided the same XPath here, the same XPath, but we're going to change here just the ID. In order to, as you know, many often in our tests, we have arrange, act, assert phases. To provide all of the necessary information about our products, I created a special class called product details. And you will wonder, what is this data? It comes from an extension called 𝑨𝒏𝒐𝒏. 𝑨𝒏𝒏𝒐𝒏 comes pre-installed in IntelliJ. It's like it provides additional functionality on top of Java with these annotations. Basically, if we don't use this data, we have just private fields, right? And with IntelliJ, when I press Alt Insert, we can ask, please IntelliJ, create the getters and setters for all of the fields. This is completely legal, I can do that, but instead of doing this, 𝑨𝒏𝒏𝒐𝒏 give us for example, these annotations, getter, setter, I can set them on before all of the fields, and one block on compile time will generate these getters and setters for us. But instead of repeating this in front of every private field, I can use this data annotation, and it will automatically create for us the toString method, the constructor that accepts all of these fields and initialize them, and it will generate automatically all of these getters and setters for us. Excellent, right? We'll spare a lot of things. We'll spare a lot of time. And now, in the range phase, in our test or above, whatever you wish, here I initialized the two products that we want to compare. This is the first iPod Touch that I showed you with ID 32, and also I set the different price, model, brand, and weight that we're going to assert during the compare phase. I call this object product details, so we have expected product 1, expected product 2. So this is our range phase. Many often in unit testing, we have these comments to separate the three phases: arrange, act, add, and at the bottom we will have assert, which makes our test a little bit more, maybe, maybe a little bit more readable. So here I can say like this: get ID. Then we are going to click this item, and what else? After that, maybe we can, when we click this button here, this page will show, right? And in order to compare the product, we need to click this button here. In order to do that, let's see the locator. Maybe we can get it by, I don't know, title. So we can type button add title equal to compare this product, and then we're going to click this button. If I need to do the same thing about the second product, probably I will have to repeat this again, right? But just change here the ID, which I don't want to do because this is a lot of code repetition. This is why we can create a private method here at the bottom, private void, let's call this method compare product, and here we can provide an integer product ID. It will probably throw interrupted exception, and we can copy the whole logic here. Actually, I will not, I will just copy this part. Not sure, probably at some point we can change here what we are searching for. Let's say string search input, search text, and then for the product ID we'll have to change it here a little bit. And now if we return to our tests, we can provide it like this. Here I will just type what we're searching for, IP, and for now everything is fine. We need just to click now this compare button on top. How we can do that? Maybe let's expand it. Maybe we can find it by this area label compare. How we can do that? This is just an anchor that has this area label compare. and we'll just click it just to load this screen, right? And as we discussed, in order to be sure that everything has been loaded, we'll pause again the execution for 2 seconds. And now it's time to assert all of the products on this compare screen. Let's be sure that we added all the items. Product compare. Even now we have 3 items. As you can see, this is one big table. It can be sometimes it can be hard to verify such tables. So if we first need to verify the product, as you can see, we have a table, then we have a table body, tr is the table row, and then we have the particular cells, which is td, and then we have a link, and maybe we can write the locator based on this first column where we have these labels, which marks what is displayed in this particular row. So let's type that. We first have table, then tbody, then what else? Then we have table row, td, and then as you can see, we selected the actual label that we have in the first cell, which which can be like the not the subtotal, but maybe we need to select the product. And we can do that by using the text.xpath method equal to product. And now we selected this particular cell, right? But we need to find basically the next 4 cells, depending on which particular column we are going to check. And we can do that by saying following sibling. This is XPath access. I suggest you, if you are not sure how this works, there is this excellent site 𝑨𝒏𝒕𝒐𝒏 and also there are some awesome videos on the Learn to Test channel about XPath. So the following sibling basically says find me all of the cells that are just below this one, not inside but below. It has a specific syntax. We need these 2 columns here and say td, and then we can say the first, the second, the third, and basically changing by this number will change which column we are searching for. And we can repeat the same by just changing here the label. For example, here I can say price, I can say brand, and as you can see, we are moving the lines by changing the label here, which is excellent. And we can reuse that. We can format this in a string format, and then we can verify it. Again, in order to not basically copy paste everything, I already created this method and I'm going to show it to you. Here it is. And I created also one more method for the XPath. This is basically in order to use the XPath, we have this private method. Let me make it more visible to you because it's long, but basically this is private method that returns a string. It accepts the cell name, or basically this is the label, the product, price, etc. And product compare index is which column we want, the first, the second, the third, or any number that we are following. It's the same XPath, table, tbody, table, row. We have the text, but here we are replacing the actual name with the cell name, and here the index will be this product compare index, which will be 1, 2, 3. And afterwards we have this big method called assert compare product details. As you can see, we are providing one of our product details objects, expected product 1 or expected product 2, which column we are checking, the first, the second, or the third. And then we're getting all of these cells here. For example, if we're providing 1 as the compare index, we'll get this field, this field, this field, and the weight. And we are using our method for generating the XPath, where we are providing these different labels here: the product, the price, the model, the brand, and the compare index. And afterwards, we are just comparing them using assertions with JUnit. We're just checking them whether they are equal. And in order to use them, we just call these two methods here, right here. Expected product 1, expected product true, and we're saying for the first expected product, compare it with column 1, and then for the second with the second column. That's all. If we have more products that have been added, we will just add them here. One more time we're going to compare them, and one more time we're going to assert them. That's all. And now, if you execute this test, what is the big problem? The big problem is that now we have one hard-coded pause equal to 2 seconds, then one more equal to 5 seconds or more. I think we can provide one more probably after clicking here the buttons. This means that here this is just 5 seconds or 10. But if you have 1000 tests, you can multiply it by these hard-coded pauses. The big problem is that this is wasted time. For example, many often instead of 5 seconds, this will probably you might need just 1 second or 2 seconds. This means that we have a waste time of 3 seconds for each test. By 1000, this is you can imagine 3000 seconds. But this is just for one of the places where we provided this thread sleep. But the worst thing is that this leads to a lot of flakiness, because many often, for example here, in certain scenarios 2 seconds might not be enough, and which means that, for example, your site might need 3 seconds or 4 seconds, and this will lead to unpredictable tests that are failing. So in order to solve these problems, the suggested way of handling this is to use the WebDriver wait. This is a special class in Selenium that can wait for many different things, but one of them is to wait for elements to be visible on the page or to exist, which are two slightly different things that we are going to discuss. There is a whole video about WebDriver wait and how to wait for different things on the Lang test channel that I created in the past. You can check it, it's awesome. You will find it in the description below. But let's really quick check how we can optimize this test. We can copy the things that we have for now. Let's say this code here. I will just copy paste here. Also, for this refactoring, I'm going to run the tests. Until now, they were made to be run exactly on my local machine, on my local browser. However, this time I'm going to run them in the Lang test cloud, which gives you many awesome capabilities like all combinations between browser versions, operating systems, etc. You have videos for the whole execution, videos, for example, for different actions that you do on the elements, which can be an excellent resource for troubleshooting. And there are many more advanced things, like, for example, changing the network throttling, simulating geolocation, time zones, etc. There are different videos on the Lang test channel that discusses these topics, so if you're interested, you can check them. But basically it gives me the flexibility to execute my tests on the platform and watch the execution. I already did that here. Many times, as you can see, it's completed and I can watch the videos. In order to do so, using the capabilities generator that I showed you here, this generator will generate for you the different usernames, passwords, etc. Basically, this is auto-generated for you, and then everything is the same. But instead of using the Chrome driver, you use the remote web driver with your username and authentication key, which are usually provided in environmental variables. They are stored there. And afterwards, we have the same test. The only difference here, on top of the things that we had before, is that I initialized this WebDriver wait, and I said that this is called an explicit wait, which means that the maximum time that we'll wait for something will be 30 seconds, or the seconds that you specify here. Actually, inside of it, it's really interesting, because actually inside of it, we will again use the thread sleep, but we'll do many smaller and shorter iterations with thread sleep until a particular condition is met. Usually this condition is like, for example, this particular element to be visible or to exist, and then continue. But we'll wait just the exact time that you need before we proceed. Let's see how we can remove these pauses, right? This biggest pause here, how we can change it. So we have the XPath, and before this line here, we'll use the wait. So here for the wait, we have this until method, and then we have these expected conditions, and then we have a method called visibility of element located, which accepts a bilocator. And here I am going to provide the XPath that we generated above, and basically this will wait until my element is visible, and then it will assign it here. We no more need this, we no more need the thread sleep, and this will solve all of our problems. When this needs to be 5 seconds, it will be 5. When it needs to be 8, it will be 8. But if it's 1, it will be 1, and it will optimize significantly our tests. And we can do the same for the second thread sleep here. I can comment it here, and right here we can wait for this particular product, like this. Again, wait until expected conditions visibility of element located, the bilocator, etc., etc. And again, the interesting thing is that I even opened the Fluent Wait class that actually contains this until method, and you'll be curious to find out, as I said, that inside of it we're again using thread sleep. Like here, we're doing the thread sleep, and this is, by the way, an interval that you can specify. Usually by default this is 1 second, but you can decrease it and make it much smaller, but you need to be careful because this is making like a web request to the server. So probably the most optimal is like half a second or 1 second. And many often when we do, for example, waits, again, check the video about how on the Lambda test channel there is a video about waiting for and handling the WebDriver wait. There, in many more details, I'm explaining this wait class. Just in short, we need such logic not only for waiting for web elements to be clickable, or to have a particular title, or for a particular iframe, but many often when we write mobile web tests, desktop tests, we need to handle like database calls or web API calls. For example, we need to wait for the server to process some information and something to be inserted in particular database table. Then we need a logic to be able to wait for this to happen. This is often happens in many enterprise projects, especially the ones that I'm working on. And we have similar wait classes. As you can see here, we are accepting a supplier action, which means any action that you want. This might be a web API call or database call. We supply what is the maximum duration and the sleep interval. This is the thing that I told you. This is for how much time we're going to wait between, again, checking the same condition. But actually the condition here is if there is an exception, we repeat the same thing, right? And we can ignore some exceptions. You can do the same with the WebDriver wait, the same logic. So this will handle a lot of the, because many often our UI tests, they're not just checking the UI, but they're working with both web APIs, database calls, etc. And because of that, they are called many times system tests instead of end-to-end or UI tests just. And in other cases, you might need to use JavaScript, like here. In this JavaScript, we're waiting for all active AJAX requests to finish. This is another technique, but it really depends on your front-end technology. So we optimized our solution, which is great. I think I hope that all of these techniques were useful to you, and you learned some techniques how to write proper locators. Many thanks for watching. If you have any questions, put them in the comments below. I will be really curious to find out what you want to watch next. Be sure to check the blog of Lambda tests. Many awesome articles are published each week. And don't forget to get your free certification on the Lambda Test website about JUnit, Selenium, and many other things. Thank you for watching, and see you in the next video.